Hello everyone. This is always the best slot I love because people are waiting for the lunch and they just want your talk to be finished as early as possible. So that's good. I would be talking about interesting topic, chaos testing. I think few already know about that. Few want to do this, but management doesn't allow you. So that's always a thing. In my talk, I'll try to raise awareness about what chaos testing is all about, how you should go about that if you get a chance, and how you should convince your bosses to allow you to do this chaos testing. It's slightly controversial because I'm asking you to test on production systems, which is, of course, it has its own dangers of testing production systems, but how to go in a structured way to minimize the damage, but still find the best out of this testing. So vaccinate your software, build its immunity, talk about chaos testing. Very quickly, who am I? So I'm a son, a husband, and a father. I live with 3 strong females in the same family. So you know, I know how to manage things, right? Your mother, your wife, and your daughter. I'm a tester at heart. All my job is testing. But with your seniority and everything, I also have to manage people a lot. So I think managing kids at home gives me a lot more opportunities of managing freshers in your job because they all are of the same age. So things become much easier there. I'm speaker by choice. I started speaking way back in 2012. That was my first talk in Spain. And then I developed this, I would say, addiction of speaking. I'm keeping a count of my talks. I cannot compare myself with Marit, for example. She has 537 talks. So I don't know when I would reach there, but this is my 41st on European stages. So I'm quite happy about that. Designation-wise, I'm a head QA and delivery manager. So as I said, I lead the QA teams. So we work for a company called Metacube Software. That's a Jaipur-based company. And we are primarily into offshore. So I see stories around me because every offshore customer gives you a different challenge. In terms of technology, in terms of people, in terms of even managing behaviors, right? So those are the things that I do, and I love processes. I love putting accountability into process. I give like leadership opportunities to each and every person in my team, so that I'm free and I can speak on stages, and those guys are working. But then, of course, they need to be accountable for what they are doing. So this is all about me in short, and let's quickly jump on to the main topic, the chaos. This is the office chaos or a real life chaos, right? Everyone is running, papers are flying, we are not sure like what exactly we want to do and other stuff. But how this relates to the software systems where we work. Look at this, a very simple animation, or not animation, a static image where someone talks about how to bring more data reliability, and everyone in the team is giving their suggestions. Look at this third guy, break pipelines on purpose. Good idea, but what is the output of it? Of course, no one allows us to test on production systems or test anything which is working fine, because customers are using it. And whenever we get a chance, we feel like this. Yeah, tonight we test on production systems. It's like a war because it has its own drawbacks, own dangers, own positives, own outputs. And we need to be quite clear about this. Why, when, how, all these things that come into our mind. So let's first see what exactly is chaos engineering. If I just go by the technical definition, which is present on Google, but I still want to read it out. It is a highly disciplined approach in testing a system's integrity by proactively simulating and identifying failures in an environment which leads to unplanned downtime or negative user experience. So the first words are important. It is a highly disciplined approach. There is no random testing here. You have to go step by step. Because at the end of the day, it is your production system. It is a system where all your business is happening. A single service breakage or stoppage can have disastrous effects, both in terms of financing, in terms of reputation, and of course, in terms of all your company's output. So that is what chaos engineering is. And why the term is put as chaos? Chaos engineering or chaos testing does not mean that we are breaking the system. It's just like when you take a flu shot, it is not making you sick. It is putting some outside object inside you so that your body becomes immune and the body starts responding to that. So next time when that same disease like enters into your body, if you are traveling somewhere, your body knows how to react against it. Similar thing we are doing it. We are putting some, I would say, few harmful objects into the system, not for breaking it, but to make the system more strong against those problems, so that when those problems come again, right, not intentionally or maybe intentionally, we don't know, the system knows how to respond against it. So it's like a vaccine. We use it as for immunity building. Let's quickly see a little history about it. This is not a very old topic, old term. Topic is always old because production systems were always available to us and the challenge always remained the same. But this term, chaos engineering or chaos testing, was actually like a decade back. So in 2010, Netflix decided to move its entire monolith code into AWS. And why it did that? Because it wanted its systems to become reliable. This was a time when Netflix started expanding its services to the entire world. Earlier, it was more restricted in US, but then it entered entire world. When you say entire world, and if you talk about countries like India and China, 1/3 of the world's population in just these two countries. So which means any system to work perfectly fine or near perfect fine with audience of these two countries, it has to be like tested perfectly. Because the amount of people using these services is like scaling something from 2,000 users to 2 million users. So you need to have your systems quite strong. So Netflix thought that their existing infrastructure at that time was not sufficient enough to basically go to this scale high. So they said, okay, let's go to AWS. They have quite well-defined architecture, well-defined servers and everything. But the problem was they had this entire code as a monolith code. So they started breaking it down into small services and move one service at a time to AWS. Now, what helped them is like when they put one service in AWS and ensured that it worked fine, and they put the next service and connected both, it started breaking. So they said, okay, that's a good way to test whether individual services can break the system or they just break on their own. So that's how they developed this tool called as Chaos Monkey. The term is quite easy. You can understand it very easily. You basically put a monkey inside a room full of objects. Close the room for 15 minutes. Now, monkey being monkey, it won't sit ideally, reading a book or something. It will just go and explore the entire room in whatever way it wants. So it will break certain things will fall on the floor, but don't break. After 15 minutes, get the monkey out, go inside, and then see what all things broke, what all things stay intact, what all things like got some scratches, but they are still fine. Repair all those things or replace all the things that broke, put the monkey again in, and allow him to play. Even if you don't allow, he will play, right? So just allow him to play, go after 15 minutes again, and then see whether the things which broke for the first time are still intact. That's exact principle this tool is doing. So what Chaos Monkey does is just go inside the systems and randomly shuts down any service it wants. And then the engineers are present right at that time to see whether the closing of that particular service has any adverse effect on rest of the services. If the system goes down or if the system shows signs of going down, they repair it immediately. So it's like a real-time testing on real-time systems. And that's how this thing came into existence. Now, within 1 year, they realized and recognized that this tool is actually doing wonders for them. But this is just about stopping services and starting services. And real systems, the modern day systems, are much more complex than starting and stopping services. So within 1 year, they came up with this entire army of monkey families. And they call it as Simian army. And you have chaos monkey, which is already there, janitor monkey, which identifies and disposes unused resources, chaos Kong, who drops a full AWS region and then see what is the effect of other regions. Similarly, conformity monkey, latency monkey, doctor monkey, security monkey, chaos gorilla, and few more. That's an entire army of tools which basically kept on working, and Netflix becoming better and better and better. Still, Netflix shows some signs of going down, but it does relatively well given the amount of traffic it receives every minute, right? So that was in 2011, and everything, all the experiments went well, much, I would say, to people's happiness, because when I see movies back home, I don't see like the Netflix going up and down, the movie goes smooth. That's a very quite smooth experience you have. And then in 2020, in the 8th update to the well-architectured framework of AWS, it was announced that chaos engineering is now the part of this entire architecture, which means chaos testing is requirement to be declared as the system as a reliable system. So within 10 years, the advent of this technology or approach or process, whatever you say, it has reached to a completely new scales. So this is about how it came into existence and where it is today. Netflix works on 2 principles, very simple principles, easy to understand, no technology here. Individual service failure should not fail the entire system, right? The diagram says it all. Keep testing, make sure your entire system works perfectly fine. And the second principle is, do not believe that you can prevent this from happening. It will break. It will go down. And that's why continuous testing here is very important. You cannot just do chaos testing once, yeah, my system is working fine, and then you stop doing it. Modern systems are not a single piece of code. Modern systems are thousands, millions of services talking to each other, situating globally apart, being worked upon by different teams who have never even met each other, right? Having standardized protocols where 2 components talk to each other. They are very, very challenging things. Modern systems are not simple systems. And with this infusion of AI and machine learning and IoTs and green IoTs, you cannot just write a piece of code and say, oh yes, I host it on some server. Everything is written in ASP. There is a JavaScript, and then there is a backend. That's it. No, we are not in that age now. So that's why we have to make sure services communicate with each other, the services work well, and even if some service goes down, there is always remaining services which should still keep the server up. So it is a well-defined system of set of processes, and these are the 5 processes or 5 steps that we need to ensure that we put into our plan before even starting or even discussing about how to go ahead with chaos testing. So you have to build a hypothesis around a steady state behavior. Identify all the steady state behaviors, and then we build hypotheses, vary the real world events, run the experiments in production, automate, that's everywhere, and then minimize the blast radius. Let's see one by one. Build a hypothesis around steady state behavior. I just go with a very simple example to make you guys understand this. Under dash circumstances, the security team is notified. Now, this is a very simple statement. There is a fill in the blanks. The entire team sits together in this exercise. It's not just about developers or BAs or testers. All the teams sit together, list down all the hypotheses and the steady state behaviors, and then start filling these blanks. So there is some circumstance where you need to notify the security team, and what that might be: security control violation. So if a security control violation is happening or happens, the security team needs to be notified. Now this word in red, this is being discussed and agreed upon by the entire team. So the developer knows, the BA knows when he writes the story, the tester knows when he tests it, that this is the state, this is the situation, when this notification message should happen. So which means when it is getting developed or tested, people know that, yes, why we are doing this and what is happening in this scenario. Prepare a list of all of these, and that would become a very good starting point for this. Why we need and what all we need, we are starting getting answers of that. Second is, we have to vary the real world events. Now, every real world event in every experiment is actually governed by a variable. We have one variable for one event, another variable for another event, and we need to vary it. So that means you have to be very careful about choosing your variables. Now, when I say choosing your variables, if anyone who is doing here automations or developers, they say, well, come on, that's a normal thing, right? What is new that I am talking about here? Variables are variables. I can use variable as A, or I can write a proper variable as first name or something like that. I'm repeating it here because developers tend to choose variables which basically helps their unit test to pass. Look, developers are the creators. No creator, even if I'm a creator of a painting or some drawing or some photograph, taking criticism or basically getting it tested by the testers, it's like an ego issue. I have created this. This works perfectly fine. So if testers comes with a bug and it's an age-old problem, developers tend to challenge, no, it passed in unit testing. You say, no, look, I have used this and this broke. So very reluctantly, the developers finally agree that, okay, yes, it's a problem. So that means the variables that they have chosen is sufficient enough to have their unit test pass. Or they have chosen any variables. But here in this case, you have to choose variables which actually add value to your testing, where you get real meaning out of why this variable is and what is the use of it, and what is the value that I am getting by choosing these variables into my experiments. So either developers pick any. Okay, you take any variable, doesn't matter. The test needs to be passed. Or they pick all. But here, don't pick any and don't pick all. Only receive or only use or pick those variables which are useful for your testing. So of course, we are not allowing it, and we will only select variables that we need. Use production to run your experiments. Yes, this is a real life production testing. It has its own risks. You can see it. I don't need to explain it. But it's a production testing. And this is a real picture. This is not created by someone. So bullet jackets were actually getting tested by firing real bullets. Now, what would happen if the test fails? Sorry, one test case failed, but one guy is gone. Out of 1,000 test cases, one failed. It's okay. I'm also an IoT fan, so I love talking about and reading about Tesla cars and all this stuff. One test case failed. Tesla car just decided not to take a U-turn because there was a wall in front. One test case failed, but Tesla car just crashed into the wall. Right? Similarly, those pacemakers, IoT control pacemakers inside the heart, it is constantly checking what is the heartbeat of a particular heart patient. One test case failed. So problem with the modern systems is cost of failure of one test case can be the difference between life and death. It's not a Amazon test case failing where someone can use my credit card and let's say buy things worth $10,000. It's a big loss, I know that. But then still it can be recovered, or at least your life is still there. You can still earn $10,000 in next few years. But if someone goes, he cannot come back. So that's why production testing is very, very crucial. Automate experiments and run continuously. We all know the advantages of automation. I'm not going to repeat those things. But here in this case, few things are crucial. So because they help us testing a large set of value combinations. Now, let me take one step back. Most of the testing that we perform is performed on most of the testings that you do before release, you test on staging systems, right? Staging systems or sub-production systems, whatever the terms are. Now, as a tester, the system on which you are testing, and you say that I have 100% test coverage, and all my test case pass, the automations are running flawlessly and everything is fine. What environment you are actually building your confidence on is the staging environment. Because it is working perfectly fine. But unfortunately, your staging environment is not the production environment. Because if you are 100% confident with the environments are exact copy of each other, then why it is happening and why there are millions of articles on Google or maybe ChatGPT or wherever you search, which always says that my test worked fine, but as soon as I go into production, things stop. Or there were bugs. Because we are not testing on production systems. So my confidence is on the environments which are not the real environments. So whatever approaches of whatever variety of data flows you can think about, you test on staging. But when it goes to on the real world, there are situations, there are data streams which we have not envisaged already. That means when they come in the system, they can do some harmful things. So that's why when you keep on running those automations, it keeps tracks of the data which comes in from various sources. And if there are any issues, it can record them, trap them, and of course, we can work on them at a later stage. So it is important, as I said, the scaling, because the amount of data that comes on the production is much higher in scale as compared to some 50 records or 500 records that we use as our golden data set to test the systems. And then, because the unknown parts of the systems are changed, our assumptions can be tested against a code. Finally, you have to keep the blast radius as small as possible. What do you mean by blast radius? The image, I think, is sufficient to explain, and I can put more words to it. You need to get a building down. You can take all the buildings as different services into your entire system. So if you want to work on a particular service, make sure that if it fails, the other services still go up. So this is called as the blast radius. Have the blast radius as small as possible. Now, how to do that? You can either mimic the live streams of the data that is coming in with dummy streams. That's approach number one. Second approach, which is more realistic, is the transactions that come into your system, identify those transactions and see which transactions are the least dangerous. For example, if you are a finance company and you are receiving transactions, let's talk about Amazon. So they are receiving transactions every minute, hundreds or thousands of transactions, right? Let's say if any transaction below $100 is less harmful to me, okay, that's fine. Filter all the transactions and see how many transactions less than $100 are there. If there are 1 million transactions and you know that these transactions can fail, Amazon need to pay back 1 million multiplied by $100, which is a huge number. So, okay, so this is risky. Go back. Transactions less than $10. Transaction less than $3. Okay, this is fine. And how many transactions? Let's say about 10,000 transactions below $3, which is still $30,000 for Amazon. Given Amazon's bank balance, $30,000 is okay. But if it gives very strong confidence into the system, $30,000 hit Amazon can take. But after all these experiments, if it is not giving any value, then even $30,000 is a huge amount. So you can say, okay, all the transactions below $3, I will use my services for that. So you create dummy data into your system using live streams, but the transaction value is less than $3. And then if the system goes down and up, it's fine. You can see the effects that is happening. What are the execution rules now? So we have seen the principles, how to work on those principles. And this is a very simple matrix of known and unknown. So on the left-hand side, known and unknown are the things that we are aware of or not aware of. And on the x-axis, things we understand or do not understand. Simple logic. Number one means known knowns. So things we are aware of as well as things that we understand. Things you are aware of but do not fully understand. That's number two. Things you understand but are not aware of. Number three. And things you are neither aware of nor understand is number four. That's the matrix is simple. I'll just explain it by an example. Let's say we have a region A where there is a primary node. You can say it as a primary database or something like that. and there are two replicas of it, replica 1 and replica 2. And then I replicate the entire node as a region B, which is a pseudo primary, a pseudo replica 1 and pseudo replica 2. This is my structure of, let's say, the servers or database or whatever. Now, how to go about that matrix? So let's begin with the first setting up the known and unknowns. What are the known and unknowns? The known part is, if a replica shut down, then it is removed from the cluster. So if I just go back to revise you what we are looking at, replica 1, if replica 1 shuts down, it is removed from this. A new replica will be created from primary and put in this place. So again, coming back, when a replica shuts down, it will be removed, fine. And a new replica will be cloned from the primary and put it there. So we are aware of this and we know about this. That's become our first real life scenarios and hypothesis. The second one, so the clone will occur because the logs have confirmed whether we have succeeded or failed. But the problem is the weekly average of the mean time it takes from experiencing a failure to create the cluster back, it is unknown. It can happen in 5 minutes, it can happen in 50 minutes. How many times in a week it happened? This is unknown. Then we go to the third, unknown known, the reverse thing. If you shut down the two replicas of the cluster at the same time, what would happen? We don't know. But then we have a pseudo primary and two replicas, so this entire structure will be replaced by this particular structure. The business will still be on. And finally, we are neither aware of nor we are like we know. So what would happen if the entire cluster is gone? Your primary, pseudo 1, pseudo 2, everything is gone. And will the pseudo region B, the pseudo primary, pseudo cluster 1 and cluster 2, will they replace it completely? And what happens between the time lag between them? Where will the transactions go? All these things we need to care about when we start planning for our testing, because we know that some services will go down. And then you must have a backup about that. Benefits, yes. So what I have told you about, okay, the dangers, the steps, the problems, but then why we are doing it. So there must be some benefits. First benefit is for the customer. We all are working for our customers. Of course, salary is the second part. But at the end of the day, it's customers, because if customers are not happy, if customers are not there at all, then basically we don't exist. Our companies won't exist. So first thing is customers, and they need to be happy. They don't care what you are doing in the backend. Chaos testing, regression testing, smoke, monkey, 100 names are there. So the services are available for a larger amount of time, and there are no outages. I'm watching Netflix as an end user. For me, the movie should run smoothly. Doesn't matter I'm using a 3G network or 4G or a broadband, doesn't matter, or watching it on a mobile or iPad or wherever. It should work smoothly. If I stop it at 23 minutes and 11 seconds, next day when I log in, it should begin from 23:11. I don't have to go front or back to start from where I stopped yesterday. That's the experience I want as a customer. So with this testing, customer may gain more confidence and happy in our services. Then, of course, there is a business, because business has to be there to make customers happy, and business is where we all work. So revenue losses are reduced, maintenance cost is reduced. One big thing that all businesses have to do, especially for the bigger softwares, is to create a support team. So there are developers, there are testers, but at one point of time, the development ceases or it becomes static. No new features are coming in. At that time, your support teams are very active, because real-time calls are coming. If anything happens, hey, I logged in and I cannot see my transactions. So all those L1, L2, L3, L4 levels of support team, they actually come into play. Now, if nothing is being tested on the production system, all the tickets that the support team receive, they actually come from the production systems. People use that as a live data, and they receive problems, and then they call the system, support teams. So support teams are very, very busy. And as business, we are happy because our team is working fine. But then the business people, the owners, they are not happy because a lot of escalations are coming. So then if chaos testing is already being performed or getting performed on a daily basis on the production systems, what would happen is Few bugs are encountered by the testing team themselves, and the developers have already fixed it, which means that scenario will not happen, or the chances of happening it gets reduced a lot, which means your support team will receive less escalations. Or even if they receive it, the developers already know because they have seen it in the real-time testing. So they know how to fix it and how quickly can they fix it, or what services needs to be up again. So they know the entire rules. And then the technical teams, which we all are. So of course, reduction in incidents. We know that. Reduction in on-call burdens. There are no night shifts or less night shifts. Increased understanding of the system failure actually help you put more faith into the system. Your systems become more, I would say, strong, and you are more confident with that system. And your incident management system, as I explained already, the support systems, they become much better. We are almost close to end. These are 8 fallacies of the distributed systems. Not for the technical people, but you think it as an end user. When you use internet services, when you use this Netflix and Amazons and all that stuff, we always believe the network is reliable, right? Wherever I stop, I can continue from the same place, from anywhere, from a bus stand, on top of Himalayas, in a river cruise, anywhere. It's fine. Network is always reliable. The latency is 0. I click and I receive the responses. Bandwidth is infinite. The network is secure. Topology doesn't change. Network is homogeneous. Transport cost is 0. And there is only one administrator of the entire world network. This is some of the fallacies that we live in. But to make these things happen, chaos testing or testing related to it on the production systems is very, very crucial. We have to explain to our bosses, explain to the business why we have to perform chaos testing, how we are going to do it, what are the chances that the system remains up all the time, even if we are doing the chaos testing. And one important thing here is, people always say that, okay, if you want to do chaos testing, do it on weekends, because at that time my systems are not getting used by other people. But I say no, chaos testing has to be performed in the daytime in the presence of all the engineers, so that whatever situation comes in, engineers can jump in immediately, fix it, and make sure the system is up. So quick summary, no system is safe from 100% outage, we know that. We can certainly have some controls on the impact, that again we know. Running chaos test minimizes the crashes, right? I am not saying chaos test will make the system 100% foolproof, but it will definitely improve a lot of immunity of your systems. And with the knowledge, tools, cooperation, collaboration, teams working together, I think we can give a much secured, much stronger software to the people. And the best part about us as testers or developers is we ourselves are the end users of the same systems in the evening. So in the day we are developing, testing, in the evening we are using the same systems, right? So the people who work in Netflix, they also watch movies on Netflix. So they know how an end user thinks and how a developer or a tester thinks. Thank you. Stay connected. And I'm open to any questions if you have, or time.
Yes. Thank you very much.
Thank you.